This is the post-test Unit 5 on polynomials and quadratics. This is for our students who need to retest. Let's go to work. All right, in the first 4 questions, you need to identify whether the following are a polynomial or not. If it is a polynomial, give its name by both degree and number of terms. Remember, degree and number of terms. Okay. Number 1, yes, it's a polynomial. It is a to the second degree, which is a quadratic, and it has 2 terms, making it a quadratic binomial. Number 2 is yes, it is a polynomial. It is to the first degree, which makes it linear, and it only has 1 term, making it a monomial. Number 3 is to the third power, so yes, first of all, yes, it is a polynomial. How would I know if things were not a polynomial? Well, if it had a square root, it wouldn't be a polynomial, or if it had x on the bottom of a fraction, it wouldn't be a polynomial, or if it has a negative exponent, because that would put it on the bottom. If it had, by chance, a fractional exponent, it wouldn't be a polynomial. So those are the things I'm looking for. And you can see that doesn't happen here in number 3. So yes, it's a polynomial. It's to the third power, which makes it cubic. And it has 1, 2, 3 terms, making it cubic trinomial. Number 4, I can see it has a square root there. So it is not a polynomial. I think everybody did relatively well on those 4. Next, perform the operations. Now, we need to do a better job of identifying the like terms. What are like terms? It's the same variable to the same degree. Okay, same variable to the same degree. So, number 5, I have this to the third power. Over here is 1 to the third power. So now all I have to do is add or subtract the coefficients. So 2 plus 1 is 3x cubed. Done. Now I need a squared. Here's a squared. It's the only one here, so I can just bring it down. Negative 5x squared. Done. Now I have an x to the first power and an x to the first power. Well, negative 7 plus 3 is a negative 4x. Done and done. And I'm left with constants. Negative 11 and 17. Negative 11 plus 17 is 6. And that's how I combine my like terms. The next one is subtraction. Look at that subtraction sign. We talked about that being a negative 1. And since it's a negative 1, I can distribute that to be now negative 2x cubed plus 7x squared minus 3x plus 10. Okay, so now let's put that together, our like terms. I got a cubed and a cube. 5 minus 2 is 3x cubed. Done. I got a squared and a squared. Negative 4 plus 7 is 3x squared. Done. And done. I have now an x and an x. Negative 5 minus 3 is a negative 8. And then finally I have my constants. 2 and 10 is 12. And a lot of people mess up on those signs because we didn't distribute this negative 1. Remember, when you distribute a negative 1, you just change the signs. All right. Number 7 and 8, we are multiplying or distributing. Remember, when we multiply, We multiply the coefficients and we add the exponents. So 2x times x is 2x squared. 2x times 1 is 2x. Negative 3 times x is a negative 3x. Negative 3 times 1 is 3. Now these two are like terms, so I can put them together. So just bring down the 2x squared. Now 2 minus 3 is a negative 1x, and then just bring down the 3. Moving on to number 8. X squared times x is x cubed. X squared times negative 1 is a negative x squared. Okay, now I've done that one. Now I do the next one. Negative 2x times x is a negative 2x squared. Negative 2x times a negative 1 is a positive 2x. And finally, 1 times x is x. And 1 times a negative 1 is a negative 1. Now I have a couple different sets of like terms. I've got these that are like terms, and I've got these that are like terms. So I just pull down the x cubed. Negative 1 and a negative 2 is a negative 3x squared. And 2 and 1 is a positive 3x minus 1. Cool? All right. Number 9 and 10 says graph the following quadratics with a minimum of 3 points. Now, there's a couple ways to do this. Okay. I don't know which way you necessarily want to go. Let's look at, if you want to just use the x value because it's in standard form, let's do that. All right, so let's use x equals negative b over 2a. So in this case, that would be 14 over 2 times a negative 1. Remember, a here is a negative 1, which gets me 14 over negative 2, which is a negative 7. So the x value of my vertex is negative 7. Now, how do I find the y? I got to plug it in. F of negative 7 equals negative 7 squared. I'm going to run out of room there. Let me do it down here. F of negative 7 equals negative 7 squared minus 14 times negative 7 minus 40. Okay, negative 7 squared is 49. It's a positive 49, but then there's this negative on the outside, so it's a negative 49. Negative times a negative here in the middle is a positive, and 14 times 7 is 98 minus 40. So if I take my negative 49 plus 98 minus 40, that equals 9. So the the y value of my vertex is a positive 9. So negative 7, positive 9. There's my vertex. Now I can use my a value to, from the vertex, go down 1 over 1, down 1 over 1. There is my parabola. I'll look at number 10. Number 10 is already in vertex form, which we love. Remember, we take the opposite of this one, so it would be 5, and then the one on the outside, which is a negative 7. So my vertex is 5, negative 7. Plot that, and now I can use my a value, which is the number in front of that parenthesis, which is a 1, to go up 1 over 1, up 1 over 1, and there is my parabola. I think a lot of people got that one right, so that was good to see. So there's our first page. Let's move on. Now, I think overall, most people did good on the first page, and we didn't start having problems until the second page. I will say Number 11 and 12, everybody did fantastic on. First of all, we have zeros of -2 and 6. So -2 and 6. The very middle between those two, -2 and 6, would be 2. And we had a minimum of -9. That means there's a point right there. Boom. There's my parabola. On number 12, a cannon was launched from 7 feet behind you. We are assuming that we're standing on the origin. So it was launched from 7 feet behind us. It lands 3 feet in front of us. So 7 behind, 3 in front. 1, 2, 3, 4, 5. So that would be -2 would be my exact middle. So that would be the height or whatever of the cannon. And it's launched from 7 feet behind, lands 3 feet in front, and it reaches a maximum height of 5. So here's my maximum height. So boom, right there is the vertex. There is my parabola. Again, I think everybody did really well on 11 and 12. Now, here is where we started having problems. But what I could see is the major problem was we didn't follow the directions. Factor the following quadratic functions, then list the zeros. Factor. You remember, is there a GCF? Is there a leading coefficient? And it was yes or no. It was no. We split the signs. Then we listed the factors of the constant. Oops, we listed the factors of the constant. If it was yes, we did the box method. You guys did really good on this in the quiz. However, here today, we let some of the little things that I warned you about cause us problems. I'll start with 13. Is there a GCF? No. Is there a leading coefficient? No. So split in signs. Put an X in each. Signs are the same, both negative. Factors of 8. 1 and 8, 2 and 4. Come together to get me a 6. 2 and 4. 2 and 4. But it says then list the zeros. What can I put in for this X to make this parenthesis equal 0? Remember, it's the opposite of what's here, so it would have been a +2. What can I put into this parenthesis to make it 0? A +4. A lot of us seem to forget that, and there was a lot of people who actually completed the square, so you didn't even follow the directions. Let's look at number 14, and this is the most common one. Remember, we always start with a GCF. Is there a GCF? Why, yes, there is. There is a 4, and I think a lot of people saw the 4, but remember, this one looks funny. Like there's no +0 over here. Remember, this is hinky. We can not only pull out a 4, but we can also pull out an X. Yep, there's that V8 moment. You guys are hitting yourself in the head. 4X squared divided by 4X is X. 36X divided by 4X is 9. Now, that doesn't need to be factored any further because this isn't squared. Some people tried to do that, like complete the difference of squares and factor it further. My zeros are, what can I put in for that X to make it equal to 0? 0. What can I put in for that X to make it, that set of parentheses equal to 0? A 9. So 0 and 9 were my two zeros. Number 15. This is one that you're supposed to be able to identify. This is the difference of squares. Should have been able to factor it to be X plus 1, X minus 1. And then my zeros would be a -1 and 1. Again, I'm sure you're kicking yourself because that was one we've done many, many times, and it was pretty simple. Looking at number 16, when we factor it and go through the process, you're going to see it's also special. Is there a GCF? No. Is there a leading coefficient? No. So split in signs. Put an X in each. Signs are the same, both negative. Factors of 16, 1 and 16, 2 and 8, 4 and 4, which come together to get me an 8, 4 and 4. Oh, wait a minute. This is a perfect square trinomial. Yes. Here, what can I put in for this first X to make it 0? 4. What can I put in for the second X to make it 0? 4. So in this case, I only have 1 0. For those of you who are interested, that means that at 4 right here, that's where the vertex is, sitting right there on the x-axis. So a lot of confusion in there because there were simple little things that you weren't following in step by step. Next 4, it says find the vertex using any method. I don't care what method you use, but what one did we do to find the vertex or get them in vertex form really easy? I would say that you would complete the square. Now, you could also do the x equals negative b over 2a if you wanted, and I don't care which way, but I'm going to complete the square just because, man, you guys did so good at it. It was so easy. X squared plus 8x space plus 2. 8 divided by 2 is 4. 4 squared is 16, so I have to add 16 and subtract 16. Now, this is a perfect square trinomial that factors to be x plus 4 quantity squared. Now, there's a lot of people that didn't put in 16 and minus 16 there. They put in plus 4 and minus 4. So that was one common error. But anyhow, I can finish this thing out by adding those two constants together, which is a negative 14. Now I can see my vertex easily is negative 4, negative 14. Number 18, I'm going to do the same thing. I'm going to continue this completing the square method because my middle numbers are even, so I might as well just use that method since we're so good at it. So here I have to take 2 divided by 2, which is 1, and then square it. 1 squared is 1, so I have to add 1 and subtract 1. This is now my perfect square trinomial. Its factors to be x plus 1, quantity squared, and then negative 1 plus 1 is 0. Now, I know I don't have to write that plus 0 on the outside, but I'm writing it here so you can see that my vertex is negative 1, 0. It's in vertex form. That's why we complete the square. Again, completing the square, x minus 10x space plus 19. Okay, so I got 10 divided by 2 is 5. 5 squared is 25. So I have to add 25, subtract 25. Perfect square trinomial, x minus 5 quantity squared. Add my two constants on the outside, which is a negative 6. So my vertex is 5. Remember, we always take the opposite of what's on the inside. And then we take whatever's on the outside. So 5, negative 6. Number 20, x squared plus 4x. Leave my space, minus 12. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 and subtract 4. Perfect square trinomial. Now remember, when we're doing these completing the squares, I always have to put my addition one first, right? The plus, whatever first, or it wouldn't be a perfect square trinomial. But anyhow, x plus 2 quantity squared is my factor of the perfect square trinomial. Put these two constants together on the outside, which is a negative 16. So my vertex is negative 2, negative 16. That's the way I chose to do it. Again, we could have used this x equals negative b over 2a and plugged it in, which would have worked as well. So there is page 2. Last page. Now, this first question is basically asking me to sketch a graph using the vertex and the zeros. In other words, I could factor this thing and complete square. So let me start by factoring it. There's no GCF. There's no leading coefficient, so x in each. Signs are the same, both positive, plus and a plus. And factors are 24. You got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which of those come together? You made 10, 4 and 6, 4 and 6. So what are my zeros? -4 and -6. A lot of people forgot that, hey, my zeros are the opposite of what goes in there. So there's my two zeros. So what are my zeros? -4 and -6. Let's take that same function and let's complete the square. X squared plus 10x, leave a space, plus 24. Okay, so 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25, subtract 25. This is a perfect square trinomial to get x plus 5 quantity squared. And then combine those like terms to get a -1. So what is my vertex now? It's -5, -1. My vertex is -5, -1. See how easily I did? Oh, look, -5, -1. There is the graph of my parabola using the vertex and the zeros. Now we're having fun. Now, you should be able to see at this point that the majority of this test was three things: identifying in polynomial operations, adding, subtracting, multiplying, and then factoring and completing the square. And you guys have shown me that you're good at the factoring and the completing of the square, so it shouldn't have been that bad. All right. Describe the transformation of the parent function. Well, remember, when it's in standard form, you can't see that transformation. So it needs to be in vertex form like number 23 is. Okay, so let's start with number 23 here by completing the square. X squared minus 6x plus 5. Okay, well, 6 divided by 2 is 3. 3 squared is 9. So plus 9 minus 9. That's a perfect square trinomial. X minus 3 quantity squared minus 4. So now I can see my transformations. G of x equals, I've got this on the outside, and outside is vertical. And so this is going to go, it's going to go down 4. And then on the inside is horizontal, right? And then not only is horizontal on the inside, but it's opposite of what we think. So I would think -3 would go to the left, but it doesn't. It's going to go to the right 3. So transformations here, it goes up 4, down 4, right 3. Number 23 is a little easier to see. You can see here it's going to go down because outside is vertical. So it's going to go down 3. Then this on the inside is left and right. I would think that would go to the right, but it's actually going to the left 6. And we have this negative sign out there. And it's, again, on the outside, that's vertical, so it means it's going to reflect and vertically. So reflect over the x-axis. Or if you'd said reflect vertically, that would work as well. All right. Last two. Sketch the transformations from the parent function. And the parent function is drawn for you there. So this one needs to go up to, so this point has to go up to 1, 2. And this tells me I need to go, put it here, up to. And this needs to go right, y to the right, The right's positive, Coach Herman. But remember, it's on the inside of the parenthesis. It goes opposite of what you think. This negative you would think would go to left, so it actually goes to the right 1 unit. So that would go right there. And it would look like this. And finally, this number 25 plus 9 means it's going to go, it's on the outside, so that's vertical. And it's going to go up 9. And then this is also on the outside, but it's a negative, so that means it's going to reflect. So it's going to go this way. It's going to turn upside down. So there is what your unit test should have looked like. I hope that this review is helpful for you. Have a great day.